Good morning, good afternoon, good evening. This is Mr. Payne bringing you final exam review number 5, I believe. Piecewise shifts and all about graphing, odd-looking graphs. Let's talk about the piecewise function, what it is. Remember that piecewise function is just different pieces of different functions all put together. So for example, this guy here is still a function because if you notice that this is an open dot, that is a closed dot. This is an open dot, that is an open dot. So we still pass the function rule. If I did a vertical line test coming through here, or here, or here, and notice you got a single dot way down here, anywhere on this function it still would pass the vertical line test. So one of the things that students always get goofed up on is making sure that my dots are open or closed and how we know that, and making sure that it's still a function. So one of the things that you need to remember is that your less than symbol or your greater than symbol are going to give you your open dots. Your less than or equal to, your greater than or equal to are going to give you your closed dots. Now as we read through the directions over here on the left hand side, putting the f of x under y equals, the easiest way to graph some of these, depending on your input function, is by typing it into y equals. Hitting second graph, this gives you your table, and only copying the points from the domain given. Well, what does that mean? That part there, I want you to underline that, the domain given. The hardest part that students have is understanding what to go and look for. Once you have your function, no matter what it is, they're going to give you a domain. They're going to say, all right, I want you, for this x value, I want you to write down from -3 less than or equal to x, less than or equal to 5. That is your domain given. You want to write down in your x column, and this is the hardest part in this notation right here, is what always screws kids up. They want you to write down in your x column from -3 to 5. So if I'm setting up a table from my calculator, the x values that I want to see are -3, -2, -1, 0, and so forth, all the way up to number 5, and all the numbers in between. Once you have that down, all you have to do is remember and pay attention to your signs. These guys. In this case, both of my dots would be closed. Now, if I took one of them away, if I took this guy away, okay, don't know why it's not going away, but that's all right. If I took it away and I just gave you a less than symbol, like such, then you would have a closed dot and an open dot. Let's shift gears here temporarily and talk about our shifts. Yes, I put a little pun in there. We're going to talk about how our shifts look. Don't forget that this is my linear, this is my quadratic, this is my exponential, and this is my absolute value. Put in your given equation. Look for how it moved, left, right, up, or down. Make sure that you're using these words. Don't tell me over or anything like that. I want you to know that it moved left, right, up, or down. Look for a flip or a reflection. Remember how we know about if there's a flip. If it goes from positive to a negative, we're going to flip over the x-axis there. And look to see if it's wider or narrower. So how do things get wider or how do things get narrower? Just let's remember here. If I had x squared, that's my parent function, my x squared, right? So if I multiply it by 4, I'm going to get narrower. Okay, I'm going to get narrower. Remember, think about running up this hill here, right? So if I increase the difficulty, it's going to get narrower. It's going to be harder for me to run. Now, if I decrease, if I make that 0.2, which is 2/10, it's a fraction, aren't I going to get easier? I cut it by half, okay? Now look at here, my negative x squared. I took my x squared, which is right here, and I just flipped it right over. So that's my narrow and wider flips. And the same thing goes for all of your exponentials as well, or in your absolute values. This is a quadratic, but if I had an absolute value in there, all the shifts would be the same. Let's talk about shifting left or right and paying attention to noticing here. Here's my parent function. Over here I move to the left too, but look at what's inside there. Because it's inside my parentheses or inside my house, we're going to do the opposite. So if I want to say something moved to the left, that's going to be a positive 2. If I want to say something went to the right, it's going to be a negative 2. I know that's confusing, but that is the same for all of your functions that we talk about. It's the same about your absolute value. It's the same about your exponential. It's the same about your quadratic. If something is inside the house, or your square roots even, it's the opposite. Okay? And if it's outside of your house or your parentheses for a quadratic, then it means that it's moving up and down. So for example, we're talking about this guy here. We have negative 4 and the inside plus 6. So that means I'm going to go right 4, up 6. And I check out here, there's no minus sign, so therefore we know that we are not going to do any flipping. Thank you very much. Now complete the questions to the best of your ability and bring them to class.